Hello. So in this section, in this mini topic, we're going to look at exact values of trig ratios. In particular, we're going to look at the answers we get when we do the sine, cos, or tan of the angle 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. Now, I'm gonna be honest, I think it's probably one of the most pointless topics in the course. Because obviously you got a calculator that will output for you. This is from GCSE as well. I'm sure many will remember that you might have remembered the triangle or hand trick or something to remember those without a calculator, right? But we're going to go over it here because this is a chapter, so I'll go for everything. So just to cover everything, I'll go through it here. The spec's quite vague though. I've copied the specification and it doesn't actually seem you need to know the values, which obviously makes sense because you've got a calculator. But I'm going to go through it anyway, just to match the textbook in a bit. If anyone's confused about what the textbook says, this video will help, hopefully. But do stick around anyway, because we will be looking at the cast method in this video as well. We looked at it very briefly, but I'm going to go over more examples. So it will still be helpful for this video anyway. And that method, that cast diagram, will be useful later on in the chapter when we look at solving equations. Okay, with that in mind then, so, say for example we wanted to evaluate sine of 30 or cos of 60 or tan 45 or anything like that with the angle 0, 30, 45, 60 and 90. Now the textbook does go through a method of triangles. I can't remember what the triangle is, but essentially you can use SOHCAHTOA, but you have to memorize the numbers. There's two triangles and it'll get you the angles and the sine, cos and tan of that. But what I'm going to go over is a different method instead, the one that I learned. So how this will work is, what we're going to do, we are firstly going to label, the hand has 5 fingers, right, 5 digits. So we're going to label these the angles that we need to know. So it's going to be 0 degrees there, 30 degrees in the next finger, 45 here, 60 here, and 90 there. Okay then, so now that we labelled our hand, how are we going to use this then? Well, firstly, let's deal with the sine. So we want to work out, if we want to work out the sine of all these angles, what we're going to do is, for sine theta, obviously for any angle theta here, 0, 30, 45, 60, 90, what we're going to do is we are going to start at 0 and then we're going to count how many fingers until we get the angle we want, okay? So if we wanted 45 degrees, well, we'd start at 0 here and then we'd go one finger to 30 and then another finger to 45. That'll be 2 fingers removed, right? If we wanted 60, then it'd be 3 fingers moved, because then it'd be another one, right? And then if we wanted 90, then that'd be that'd be the 4th finger, right, from 0. Okay, so that's how many fingers we used, right? So with that in mind, then to work out the sine of the angle, it's going to be the root of the fingers used over, no, I'm just going to say root fingers over 2, okay? Right, so let me demonstrate with some examples then. So firstly, if we wanted sine of 0 degrees, right, sine of 0, well, we start at 0, so we've not moved any fingers, so we're at 0, right? So that'd be root 0 over 2. Well, root 0, 0, so 0 over 2, which is 0, okay? The sine of 0 is indeed 0, which makes sense, because if you look at the sine graph, again, it looks like this. Well, at 0, it's at 0, right? So that confirms that we're right. If we then wanted sine 30, the next angle, right? Well, to get from 0 here to this finger to this finger, right, to 30, from 0 to 30, we'd have to move, oh, one finger, okay? So then that'd be root 1, okay? Root 1 over 2. And so root 1 is just 1, so we get a half. So therefore sine 30 is indeed a half. Then if we wanted sine 45, I'll do that here. Well, if we start at 0 again, 0 degrees, if we want to get to 45 to that finger, well, we'd have to move one finger and another one, okay? So that'll be 2 fingers, right, used. So it'd be root 2 over 2. Okay, and we can't simplify that, so that's that. If you put sine 45 in the calculator, you should get root 2 over 2, okay? Then what if we want sine 60? Well, again, we start at 0, but to get to 60 then, we'd have to move 1, 2, 3 fingers, okay? So that'd be root 3 over 2. And lastly, sine 90. Well, we'd have to move 4 fingers, so 1, 2, 3, and then 4 there, okay? So it'd be root 4 over 2. Well, root 4 is just 2. So we get root 4 over 2, which is 2 over 2, which is just 1. So therefore we're saying sine 90 is 1, which again makes sense if we look at the sine graph. 90 is there, which is at the top, which is at 1, okay? Cool. Okay, so that's sine of it then. That's how we'd use that then. What about cos next? Well, cos works in the same way, except instead of starting at 0, we now start at 90. Okay, and then we do the same way of going backwards of how many fingers we need to use. Okay, so I'm going to say then that cos of an angle, say theta, is also going to be the root of the fingers over 2. But this time we start at 90. And at sine, we started at 0. So with that in mind then, well, firstly, cos 0 then, in this way, well, now we start at the finger at 90, so to get to 0, we're going to move 1, 2, 3, 4 fingers, so it'd be root 4 over 2. So that'll go to, again, 1 overall, because root 4 is 2, okay, and it cancels down to 1. Okay, what if we wanted then cos 30? We'd have to move 1, 2, 3 fingers to get to 30. So that'd be root 3 over 2. If we then wanted cos 45 next, well, 45 would move, starting at 90, be 1, 2 fingers. So it'd be root 2 over 2. Cos 60, well, that would just be 1 finger then. Starting at 90, 1 there, right, to get to the 60 finger. So root 1 over 2. Well, again, root 1's 1, so it's just a half. And lastly, cos 90. Well, we start at 90, so it's just 0, right? The finger is 0 over 2, which is just 0, okay? And again, these make sense because if we look at the cos graph, cos 0, well, we start at 1, so hence cos 0 is 1. And at 90 there, we get back to 0, which again, we get cos 90 is 0. Okay, so that's sine and cos. That's how we work that out. Hopefully that's fairly straightforward. You just need to remember where we start, right? So we start at 0 for sine. Well, we don't even need to remember because obviously you have a calculator, but this is the idea of the method. But anyway, lastly we have tan. Now tan is a bit more work, but the idea is with tan, what we're going to do is we're going to use an identity that we will be using next section, but tan of an angle is always the sine of the angle over the cos of it. What we're going to do then, if we want to find the tan of these angles, we're going to find the sine and the cos of those angles and then divide them, okay? So, let's do tan 0 firstly. Well, tan 0 is going to be sine 0 over cos 0. Well, sine 0 Again, well, for sine, we start at 0. Well, there we are. So sine of 0 is just 0. So that'd be root 0 over 2, right? And then for the the cos part then, well, cos of 0, well, we have to start at 90 for cos, so we have to move 1, 2, 3, 4 fingers. So that'd be root 4 over 2. Now, actually, these 2's cancel here, so we get root 0 over root 4. Now, that's 0 over 2, which is just 0, okay? And then if we want, wanted, so that tan 0, 0, cool. Then tan 30, right, again, we want sine and cos 30. Well, sine 30, if we start at 0 again, we have to move 1 finger, so it'd be root 1 over 2. But we don't actually need root over, we only need just a finger. We only need root 1. We don't need root 1 over 2 because the 2's cancel like here. So we just need the root, the number on top, right? The finger, right? Number there. So then if we deal with cos 30 then, next. So cos 30 again, we start at 90. So that'd be 1, 2, 3 fingers. So that'd be root 1 over, that'd be root 3 there, okay? So root 1 over root 3 would be, well, root 1 is 1, and then root 3 is just root 3. We can, and there we are. We can rationalise if we want to by timesing both top and bottom by root 3. So that will go to root 3 over 3, equivalently. So tan 30 is root 3 over 3. Now, tan 45 then. So again, we need sine and cos of 45, and then divide them. So sine 45 firstly. Well, we start at 0 for sine, so it'd be 2 fingers to get to 45. So it'd be root 2. And then for cos, sorry, then to get to 45, we need to start at 90 for cos, so the other way around. So then we move 2 fingers as well, okay? So that'd be root 2 over root 2, which is just 1, okay? So there we are. So tan 45 is 1. Then if we add tan of 60, well, we need sine 60 firstly, so if we start at 0 for sine, it'd be 1, 2, 3 fingers, so that'd be root 3. And then over the cos of 60, well, we start at 90 for cos, we just move 1 finger, okay? So then that'd be root 1. And so then we have root 3 over root 1. Well, root 1's 1, so it's you just get root 3 for tan 60. And then lastly, tan 90. Well, the sine of 90, if we start at 0, we have to move 1, 2, 3, 4 fingers. So sine of 90 is root 4 over root 4 there. And then the cos, well, we're at 90 already. So if we start at 90 for cos, that's just 0 then. So we get root 0 for that. Well, 0, well, root 4 is 2, and root 0 is 0. Well, actually, we've divided by 0, so it's undefined. So tan 90 is undefined. And that again makes sense, because if we look at our tan graph, there's an asymptote here at 90. There's an asymptote at 90 because the tan is not defined at 90 for this reason, okay? And also at 0, obviously tan is 0, which again confirms what we saw up here, that tan 0 is indeed 0. So again, the graphs confirm all this, but those are how we can work that out without a calculator. Now, that probably is a bit pointless, but there is a bit of a purpose to that, though, when we look at some examples in a moment. But yeah, let's have a look at some. So, now we're going to look at using our cast diagram that we looked at last time, and this is where kind of the idea of what we just looked at, of having a way to find exactly what those certain angles are, this is where it comes into play. Now, again, you could just probably put that in a calculator and you will get the answer, but let's go over the method, because again, this method can be useful later on in the chapter, where you can't just use the calculator to get an answer. Anyway, so we need to find the exact value of sine of minus 210. So this is going to link back to what we did last time. So firstly, we just construct a grid, right? And so we said sine of minus 210. Well, that's a negative angle. Now remember, when we measure angles in this way, we start positive on the positive x-axis, right? And then we go, if it's positive, we go that way, anti-clockwise, until we do a full turn. If it's a negative angle, we need to go the opposite and go clockwise, okay, and go that way. That's how. And so then, minus 210, well, firstly, minus 90 would be there. So that'd be 90. Then another 90, 180 would be there. Then we need another 30 after there. So that means we would have an angle there at 30, okay? So overall, the angle we get with the 30 and 180 would be 210, and it'd be negative because we go in the clockwise direction. So there we are then. So actually we can kind of get rid of this because we kind of get a triangle then, right? And so what this is saying then, if we then label the diagram as CAST for cast, this is saying that sine of minus 210 is going to be equivalent to sine of 30, right? So what angle we get with the axis when we find the whole angle, right? That is equivalent, right? So sine 30 is equivalent to the whole angle of minus 210 that we have, right? So this is how we can do it. Now, why we're doing cast is because actually, whilst it's equivalent, it'd be plus or minus, right? Because of the fact it could be on the negative x-axis or the positive x-axis or vice versa on the y. Now here we have negative x and negative y, and positive y, sorry. But we can use this cast labeling to help us just tell us the answer. So again, cast, well, C represents cos, A represents all, meaning cos, tan and sine, S represents sine, and T represents tan. Now these tell us then if our angle or our line is in the quadrant, so it's in this quadrant with S, that means that the sine has to be positive, right? It has to be a positive number, meaning that sine of minus 210 will be equal to positive sine 30, right? So it'd be just sine 30 then, okay? Well, therefore then, this is saying that sine of minus 210 is just sine 30, okay? Very simply. If, say, it was sine 30 that way, in this axis instead, well, only tan would be positive at the angle. So sine would be negative, okay, if it was there, say. But because it's in the quadrant with S for sine, sine has to be positive at that angle, okay? So it'd be positive 30. So that's the whole idea then. We're going to find a smaller angle version equivalent to the larger angle we need to find, okay? Anyway, well, if it's equal to sine 30, well, we know how to find sine 30. We just did it, right? We can say use our hand method, right? If we draw a very poor hand, or you could preferably just visualize how to do it, right, at this point, or just use a calculator, of course. But if we're going to use our method we just learn, hopefully I can draw a somewhat. There we are. Okay, I don't know. That's something. Okay, not a hand, but yeah. Anyway, so again, we're going to label our 5 fingers. They are fingers at 0, 30, 45, 60, 90. As always, that's what we'll always be doing. So we're going to start at 0 because it's sine, and then work our way around. So we want 30. We want the angle 30. So if we're starting at 0, we'd be moving one finger. So it'd be the finger, which should be root of the 1. So root of the finger, which is root 1, over 2. Always over 2. Well, root 1 over 2, that's just 1 over 2. So there we are. So therefore we can deduce sine minus 210 is indeed a half. Okay. And so there we are. And so this is why, by the way, it is useful to find a way without a calculator to find the answers, because you think back to the past, maybe there wasn't technology there to have calculators to give you the answer. So mathematicians found other ways of finding these smaller angles, and then when we can find the smaller angles, we can use this cast method or otherwise to find larger angles that are equivalent to it, right? And so we can basically find every angle essentially using this method by breaking it down into a smaller angle that we do know the answer to. Okay, so I'm going to practice some more then with this cast method because it will be useful later on in the chapter. So firstly we need to find sine of 135. So I'm going to again find the angle for 135, right? If we're going to go that way, because it'd be positive 135. Now, we would have to move 90 that way, but then and we'd have to move another 45, right, that way. So then overall, 90 and 45 gets me 135. That's my angle. Right, but we want to measure it from the x-axis, right? That is, again, that line there, the x-axis, right? So actually we can also say that this angle then, almost like a triangle then we make here, well, if that region's 45 and we know it has to add up to a 90 in a quadrant, then this angle here is going to be 45 as well, because then 45 and 45 is 90. Okay, so now we got this sort of triangle. Now that's telling me then that this angle of 135 overall is also equivalent to the 45. Right, so then sine of 135 is sine 45, but it's plus or minus because again it might be on the negative axis compared to the other, right? So we just need to account for plus or minus. How do we determine if it's plus or minus? Well, we use cast, right? So again, we're in this region, right? So the second quadrant, so that would be only sine that's positive. Well, that would mean it has to be positive then, because we do have sine, okay? So sine 135 is actually sine 45 positive. So there we are. Well, we can work out sine 45. Again, we can maybe use our hand method. I'll do it down here. Okay. 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 I don't know what that is. So we have 0, 30, 45, 60 and 90 there. Terrible drawing, terrible. But we want sine 45, and because it's sine, we start from 0. So we're going to move 1 to 30 and then another finger to 45. So that'd be 2 fingers there, right? So that would be root 2 over 2. And we can't do anything more with that, so we can say that sine 135 is also root 2 over 2. Okay, then part B then is sine of minus 60. So then if we do that angle, well, it's negative, so we're going to go that way around, right? So we're going to go 60 then below. So it's going to be looking like that with an angle of 60. Okay, so that's the angle between the x-axis, right? Then, well, sine of 60 minus 60 is equivalent to sine of positive 60, right? That's the angle we got between the x-axis, right? But again, is it plus or minus? Well, let's do cast. Well, in this quadrant, in this space, it's only C because that's positive. So that means sine has to be negative. Sine of our angle that we want is negative. So we have to whack a negative in front of this, right? So negative of sine 60. Now, what is sine 60 then? Well, again, we can resort to a hand method. God, here we go. Okay, so we'd label it 0, 30, 45, 60, 90. So we're going to start at 0 for sine. So we want 60. So it's going to be 1, 2, 3 fingers to get to 60. So that'd be root 3 over 2. So minus root 3 over 2. And there we are. So that means, therefore, that sine of minus 60 is minus root 3 over 2. Okay. Now, part C, we want okay, yeah, I did okay, they're not in order, so we don't have part C next, we have part F to pick different questions, right? So part F now is cos of 120 is what we need to find. So again, we draw our angles. So we want the angle 120. Firstly, we need to go 90 there, and then we need to go about 30 over there, right? So that'd be another 30. So overall, the 90 and the 30 gets me the angle 120. Well, if you have a 30 angle there, that means the other angle has to be a 60, right? Between the x-axis there, okay? Okay, so again, this 60 angle is equivalent to 120. So that means cos of 120 has to be some positive or negative of cos 60. Well, what sine is it? Well, we use cast. Well, we're working in this region. That's where the 60 angle is. So only sine is positive. So cos has to be negative there, okay? So then to find cos 60, okay, so if we do our hand, okay, so that'd be 0, 30, 45, 60, 90. So for cos now, we have to start at 90. So to get to 60, well, we only have to move one finger, okay, to get from 90 to 60. So that would be root 1 over 2. So minus root 1 over 2, which is just 1 over 2. So therefore, cos 120 is minus a half. And there we are. Okay, part G, we need cos of 300. So again, if we draw our diagram, so we need to mark 300 on here. So actually, if we go 3/4 of the way through, that'd be 270, right? So then we need another 30, right, to push us to 300. So it'd look something like this, where that angle will be 30. Well, then we can find this angle here then between the x-axis, right? So it overall has to be 90, so that would be 60 then, right? And so therefore then, the angle 300 overall is equivalent to the 60, but is it a positive or negative of cos 60? Well, we're going to use cast again. Well, in this region where the 60 is, if we label the what we have, the C, well, that means C for cos is positive, right? So it's just positive for cos 60. So there we are. So it's just cos 300 is equal to cos 60 there. So then how do we find cos 60? Well, let's do a hand again. They're getting worse each time. So we have 0, 30, 45, 60 and 90. So to get to 60, well, obviously, again, we want, for cos, we start at 90 instead, and we go the other way around the hand. So we just, again, move one finger from 90 to 60. So that'd be root 1 over 2. So there we are, root 1 over 2. Well, that's just a half. Therefore, cos of 300 is equal to a half there. Great, and then the next set of questions, part K, we need tan of 135. So hopefully the method of the cast to get the angle is fine. Hopefully that's sort of sinking in. So tan of 135, we were to mark that. Now again, we're going to go that way because it's positive. Because it's positive. So it'd be 90 first of all, and then we need another 45, right, to get to 135 overall. So it'd be something like that with 45 there and a 90 there. Well, if you add them, you get 135. Okay, so the overall angle, so that angle's 45 and that angle's 90. The overall angle's 135. Now we can then find this angle it makes with the x-axis again. Because then if that's 45 there, then this angle has to also be 45 to overall, because every quadrant has to be 90 degrees, right? So there we are. So this tells us that tan 135 is equivalent to tan 45, but it'd be plus or minus. What sign is it? Because obviously the sign again can vary, because it might be on the negative x-axis or positive x-axis, vice versa. But or positive or a negative y-axis, right? We looked at that in the first section, right? The x was the cosine and the y was the sine, and the tan was the y over x. But we don't have to bog ourselves down with this because we can use cast again to just tell us what sine it is. We don't have to worry about any of that. So again, we're in this space, so that'd be the S here in this quadrant. So that's telling me only sine would be positive here. So tan would be negative, so we have to whack a negative on. Well, to find tan 45 then, if I do a little hand, say over here. Okay, so that'd be 0, that'd be 30, this will be 45, this will be 60, and that'll be 90. So firstly we need, remember with tan, we do sine over the cos. So firstly we need sine. So we're going to start at 0 for sine. So that'd be 2 fingers to get to 45. So that'd be minus of root 2 for the sine. And then for the cos part, well, we need to start at 90 and then get to 45. So that'd be 2 fingers as well to get to 45. So that'd be root 2 from the cos. Well, that cancels, so we just get minus 1. So therefore we can say that tan 135 is minus 1. Okay, then lastly, we need tan of minus 225 part L. Uh, 225, right? All degrees, right? Yes, okay. So then we need to mark that angle on our diagram. So it'd be a negative 225, so it's going to go that way, right? So if we then do half of it, it'd be 180. Then we need another 45, right, to get from 180 to 225. So another 45 angle there. So there we are, right? And so that's telling me actually the angle between the x-axis then is 45, right, in this space. So this is telling us that tan of minus 225 is equal to, well, equivalent to the tan of 45, but it'd be plus or minus depending on, you know, the negatives or whatever we have. What sign is that going to be exactly? Is it going to be plus or minus? Is it plus or minus? What is it going to be? Well, again, we're in this space, so that'd be for S then, so only sine is positive, so the tan has to be negative of this. So there we are. Well, actually, we already worked out tan minus 45, and that turned out to be minus 1, okay? I'll leave you to do that by yourself. But yeah, we can use the exact same method we did before. So we get minus 1 as well. So therefore, tan of minus 225 also gets us minus 1. Cool. Okay. So okay, so that's just, so hopefully you got a good idea, hopefully now with these examples, that the whole idea of how using cast to find, you know, tan, sine, or coses of different angles, how we can split it down into smaller angles that the calculator will get us, right? But yeah, and of course you could put all this in the calculator now, but we will look at examples when we have x's, and obviously the calculator won't like, it can't work with variables, right? So this is where we need to get the method and the idea behind the method before we can then apply it to harder examples later on in the chapter. Anyway, so I'm going to finish off with the last example. And this won't be necessarily just learning, you know, the rate, the numbers. It's a bit of a harder question, some trig involved, trigonometry. But yeah, so this is a nice little challenge question. Not too bad, actually. Really isn't too bad for a challenge question. So let's work through it. So we are told that we have an isosceles right angle triangle ABC, which is the overall triangle here. Now it's isosceles. Now, we have an angle at 90, so that means this angle has to be 45 at A, and at C, the overall angle has to also be 45, okay? Meaning the base angles are 45, so this side would be identical to this side, okay? So yeah. Now, okay, we're also told that AE and DE are 1. Well, they've told us that here, and the angles that we need to work with are 30 and 45. We first need to find the length of CE. So that would be correspond to that triangle. If I draw that triangle out then, so we have CED, that'd be 1. This will be 30. So we need to find this CE, right? Well, if this is a right angle triangle, right? Can't we can just use SOHCAHTOA here, right? So CE here, that is adjacent to the angle 30, right? And this 1 is opposite it, right? So we can use the tan part of SOHCAHTOA. So tan of 30 is the opposite, which is 1 over the adjacent, which I'm going to call just CE, right? Or I could call it X, I guess, if I wanted to. X. So then I can then times both sides by X. Well, actually, no, let's work out tan 30 first. So again, we can use our hand method. Okay, so we have 0, 30, 45, 60, 90. So for tan 30, I'm going to do it over here. First we need to remember divide the sine of the over the cos. So dividing sine. So first we need sine of 30. So we're going to start at 0 for sine. So that'd be 1 finger. So it'd be root 1 for sine. Then for cos, well, we need to start at 90 then, don't we? And if we need to get to 30, so that'd be 1, 2, 3 fingers to get to 30 from 90. So that'd be root 3. Now, root 1 is 1 over root 3. And we can rationalise that. And so we get root 3 over 3. So therefore then we can say root 3 over 3 is 1 over x. And then we can sort of cross multiply, right? So therefore we can say x root 3 is 3. So x is 3 over root 3. And then we can rationalise that. And then we get 3 root 3 over root 3 times root 3 is just 3. Well, the 3's cancelled, so therefore x is just root 3. So CE, we can add that onto the diagram, is root 3. Okay. Okay, obviously the calculator would obviously give you basically the whole answer there. I didn't have to work out tan 30, and it does simplify the surds as well, but I thought I'd show the full thing, right? Anyway, for part 2, we need to find the length DC. So that'd be that side. So that'd be this angle, right? If I call that then that length Y, that'd be DC. But again, I can use SOHCAHTOA, right, to find that next part. So to find Y, or the length DC, so Y is the hypotenuse, right? Because it's opposite the right angle, right? So we're gonna add, so let's all, and then the 1 is the opposite. So we're gonna need the sine part of the SOHCAHTOA. So sine of 30 is going to be the opposite over the adjacent of the hypotenuse. So that'd be 1 for the opposite, the angle 30, and the hypotenuse is Y. Where again, we can find sine 30, but we already found sine 30. If you go back to our hand, if we want sine of 30, right, we start at 0 for sine, and that'd just be 1 finger. So that'd be root 1 over 2, right, always over 2. And then that just goes to 1 over 2, because root 1 is 1. So therefore then we could say that 1 over 2 is equal to 1 over y, because sine 30 is a half. And then we can sort of cross multiply if we want to. So y, or 1 times y, because this is what I'm doing. 1 times y is equal to 2 times 1. So that'd be 2. And there we are. So y equals 2. Probably could have spotted that, right? Because the denominators have to be the same, so y is 2. But that's the formal way of solving it. I'm doing a lot of hard work for very simple stuff here. But there we are. So then we can add that DC is 2 there. Okay, then we need to find the length BC next. So BC is on the big triangle ABC, right? So let's consider now the triangle ABC. So if I draw that then, oh. So we have the triangle ABC now. Oh. So that'd be a right angle at B. That's A and that's C. We need to find the length BC. I'm going to call that a different letter Z now. And we know that also we know that AC, well, we know AE is 1 and EC is root 3. So overall, AC, the bottom side, is going to be 1 add root 3, right? Cool, but we also know that because ABC is isosceles, that means two sides have to be the same. Well, the two sides have to be by the base angles, right? So 45 there. This would also have to be 45 as well, because then the other angle's 90. So therefore, these two angles, the angle at C and the angle at A, has to be 45. Because it's isosceles, right? Because then that side is equal to that side. But this side's also going to be Z then, isn't it? Right? Now again, we can use SOHCAHTOA then, right? Because we've got a right angle triangle. Well, and we got all the angles actually. Take your pick. But we can use SOHCAHTOA in this case. So firstly, let's just take this angle. It doesn't really matter, does it? But let's work with this angle 45 then. So this 45 is opposite the Z, right? Which you want to find. No, actually, no, let's not confuse it, right? The question wanted BC, which is this side here. It's also equal to this side, because again, it's isosceles, two sides are the same. But then it's opposite this angle 45, right? So it's going to be opposite, and also we know the hypotenuse, which is opposite the right angle, which is root 1 over root 1 add root 3. So we can use the sine again, right? So SOHCAHTOA. So then I can say that sine of 45 is equal to BC, which is Z, which is opposite that angle, over the hypotenuse, which is 1 plus root 3. Okay. Now, sine 45 then, obviously again, best put it in calculator, but let's just, to cover all ground, let's just work it out using this method. 1, 2, 3, 4, 5. And by the way, if you have your own method, like I know a lot of people like the triangle method, which the textbook and wherever else does it. Whatever method really suits, doesn't really matter, as long as you can work out the angle. So we have 0, 30, 45, 60, 90. So then we want 45. Now because it's sine, we need to start at 0. So we're going to go move 1, 2 fingers. So sine of 45 is going to be root 2 over 2. Okay. And so then that's going to be Z over 1 plus root 3. And so then I need to cross multiply. Because then I'm going to say 2Z is going to equal root 2 lots of 1 plus root 3. Okay. Now I could times it out actually. So I could say that 2Z is equal to root 2 times root 2 root 3. Now remember, we can bring that inside as 1/3. So root 2 root 3. Well, we can do root 6 then, right? Root 2 times 3, which is 6. So therefore then we can say that Z is going to be a half of all this. Or root 2 plus root 6 all over 2. Okay, and that's our side then. BC is equal to root 2 plus root 6 over 2, which is also Z. Right, okay, then this fourth part is DB. So that's going to be this side there. Now again, we know that BC is now root 2 over root 6 all over 2. Now because BC, right, that side is equal to the side AB, right? Because they're both isosceles, so they're both equal. So AB overall then, I can sort of add that on then. AB overall is root 2 plus root 6 over 2 as well. So then we can find dB, that we need to find dB. Well, we can find dB by just taking this overall AB, right, this nasty fraction, from AD. We can find AD because this is the triangle we got, right? If I do it up here. The triangle ADE, so the length AD, which I guess I'll call W then, right? So that'll be 45. We know that DE is 1. We also know AE is 1 as well. And also W is a hypotenuse, right? So we can just use Pythagoras theorem, right, to find the length AD, right? So that means Pythagoras theorem means just, because it's a hypotenuse, W squared is going to be the other two sides squared. 1 squared and 1 squared. Well, that's 1 and 1, which is 2. So then we square root both sides. Well, W then is just root 2. So we then can say that this is root 2, that side. So then this side, AD, is now root 2, right? So now we can take away AB from AD, which is root 2, to get BD to that side there, okay? So therefore, I can say, I'll do it down here, BD is going to be AB take away AD. Now AB we worked out last time, which is equal to BC, which is just root 2 plus root 6 over 2 minus AD, which we found to be root 2 up here, right? There, root 2. And so we just work all that out, right? So if we work all that out, well, we can combine it as one fraction, because then if we do root, what if we then we need a common denominator. So then we need this out of 2. So we need to get 2 root 2 over 2 then, right, to get a common denominator. And so there we are. Well, then if we simplify this, well, root 2 minus 2 root 2 is just going to be minus root 2. So you have 1 lots of root 2, take away 2 lots of root 2, is minus root 2. So we're going to get root 6 minus root 2 over 2 there, okay? So there we are. So that's the length dB. Okay. There we are. Now, I'm going to get rid of this hand now. Okay, so that's all the lengths done then. Then we need to find the size of angle BCD. Okay, well, BCD is this angle there. Well, as we discussed, that overall triangle ABC, right? If I do it up here again, so that's A, B, C. Well, we know this angle's 45. That angle's 90, so the other angle has to also be 45 then, right? So therefore, so if the overall angle's 45 and this angle's 30, so therefore the other angle has to be 15 then, right? So therefore I'm going to say angle BCD is going to be 45 take away 30, which is 15. That leads us very nicely to the last part of the question, because then it says, hence find the exact values for sine and cos of 15. Now, the calculator... Oh, it does give you the answer, okay. But we can find that without the calculator as well. Now, there's no requirement to know 15 exactly. Only 30, 45 and 60 and 90 and 0. But we can use this, we can now find the value of 15, right? Sine and cos 15. Well, they're giving us a hint because they've told us to find the angle of BCD. That means we need to consider this triangle, right? DBC, right? So if I do that triangle then, yeah, that would be D there, this will be B, and we have C. Well, this angle's 15, and this is a right angle triangle. Well, we also know that the length DC is 2, right? And we also worked out in part the part 4, that part A, that DB, which is again this length here, is this third here. It's root 6 minus root 2 over 2. So if I do that here, there we are. So then we firstly then need to find sine of 15. Well, we can use SOHCAHTOA then, because we've got a right angle triangle, right? So the angle 15 is opposite this length, right? And 2 is the hypotenuse, obviously, because it's opposite the right angle. So if we use SOHCAHTOA, sine is going to be the opposite, which is root 6 minus root 2 over 2, divided by the hypotenuse, which is 2. Right? So therefore then, if you do keep flip change, so that's going to be root 6 minus root 2 over 2. I'm going to have to get rid of all this down here. I have to make room. Okay, so root 6 minus root 2 over 2, and then we're going to flip, change the sign to times, and then flip the 2. So that'd be 2 over 1, basically. So flip that, we get a half, right? So then that'd be root 6 minus root 2 over 4, right? So that'd be sine of 15, okay? And there we are. And if I put that in a calculator, I indeed get root 6 minus root 2 over 4. Okay, some calculators might not do that, but mine does. But yeah. Then the next part, then we need to find cos 15, and we can find that cos 15 then. Well, we need the adjacent, so now we need this side BC. Again, we found BC in the third part. Well, this BC is root 2 add root 6 over 2. So root 6 add root 2 over 2. That's length BC. So then cos 15, if we do SOHCAHTOA, well, it'd be adjacent over the hypotenuse. So the adjacent to the angle 15 is here. So it'd be root 6 add root 2 over 2, divided by the hypotenuse, which is again 2. So then if you do KFC, keep flip change, it'll be times a half, right? And so then if we do that then, we get root 6 add root 2 over 4, okay? So therefore then, cos of 15 gets us that, okay? And so that's the whole idea then. So if we can find ways then of finding, you know, these smaller angles, right, 15, 30, 45, 60, then we can use that to find other angles using the cast method, which you looked at in the other examples just, right? So yeah, it's quite of a step, it's quite a challenge question, right? But I think it's quite nice. Obviously the numbers are a bit weird, but once you realise it's just surds, nothing to get freaked out about, I don't think it's too bad. But yeah, so that's exact trig value. So that's where we looked at the angles 30, 45, 60, 90 and 0. But yeah, so that's it for this chapter, for this video anyway. More on this chapter in the next video, but I'll see you next time.